Simple linear regression in R. Linear regression is used to find a relationship between dependent and the independent variable. It is a kind of supervised learning where we give a function to build a model and predict the values. Simple linear regression, we can generalize the equation in a mathematical form, that is y equal to c plus m into x, wherein y is the estimated dependent variable, the variable whose value we need to find out or we need to predict. C is the constant or the intercept. M is the slope or regression coefficient. And X is the value of independent variables. So what is intercept? Intercept simply means the value of dependent variable when independent value is at 0. And slope, it is the effect of independent variable on the estimation of dependent variable's value. For example, how can we establish a regression? It is very simple. Let's take a simple example of weight and height of a woman. Whenever we are creating a function or a model to estimate the value of, to establish a regression model, we need a dependent variable and an independent variable. When we are talking about simple linear regression, it means there is only one independent variable by which we are going to find the value of our dependent variable. So I'm taking here the example of weight and height. So it is very easy to understand that when the height increases, correspondingly weight also increases. We are taking a data set that is inbuilt in R and it is called as women data set. In it, there is values of height and weight of women aged between 30 to 39. And to build a regression model, the steps are, there should be a experiment of gathering a sample of observed values of x and corresponding y. So here we are talking about, we are taking a sample of observed values of height and their corresponding weight. Next, create a relationship model using the LM function in R. So in R, whenever we want to build a model, linear model, we use a function that is LM, and within brackets we give the data name and the formula for the model. Find the coefficients for the model created and create the mathematical equation using these. So the coefficients for the model will be the intercept and the slope value, and we can see how a mathematical equation can be formed with that. Get a summary of relationship model to know the average errors in prediction, also called residuals. So what we will do is we'll create a model, we'll predict values from that, and we'll check the summary of that model in order to know how significant our model is. Last is to predict the values. So we'll be creating a new data set of height and we'll predict the value of weight from that new data. For the function to predict the values is predict function. And after that, I'll be showing you how to plot the graph and know how, if the model is meeting our assumptions or not. So let's go to R and let's build the model. So I have already written the codes for you. So the data set that I'm using is women data set. As you can see, there is a data frame with 15 observations and 2 variables, that is height and weight, and the women are aged between 30 to 39. So let's check the value of women data set. So we can see there are 15 values of height and weight. You see, as height increases, weight also increases. To check this, what we'll do is we'll check the linearity by plotting them. And to plot the values, the function is plot. Within the bracket, I'll be giving the name of the dataset, that is women $height. So what I'm writing is, I want to first take the height in corresponding with weight. So my height is the x value and my weight is the y value. Let's execute this command. So you can see there is a linearity in the graph. It can be seen by a diagonal line that is showing there is a linear relationship between height and weight. Next, we are going to build a model. So I'm taking a variable LM model and I'm giving the function LM, within which I have given weight, that is my dependent variable. So I am taking my dependent variable in relation to the independent variable. So in simple linear relationship, there is only one independent variable. Then I am giving the name of the data. So it is women data set. So I have mentioned the name of the data set here. Let's execute this model. You can see in the environment also, my variable has been saved with name lm model. Let's check the details of this model. So if I directly execute the model, what I'll receive in my output is the value of intercept and height, that is slope. So the value here, what does this say is, if we check our mathematical equation, that is weight equal to a plus b into height, where a is the intercept and b is the slope. So if I put the values of intercept and slope here, what will be my equation is weight is equal to, the intercept value is minus 87.52 plus slope is 3.45 and multiplied by height. So what it interprets is, the slope tells us there will be 4.545 times effect of height when we predict the value of weight, and intercept, it shows that how much is the value of dependent variable when the independent variable is at zero level. So if there is no height, there will be no weight. Next, let's check the summary of model in order to check its significance. Now, when we are checking the significance of a model, it is very important to check 5 factors. These are residuals, coefficients, then there is significance code, residual standard error, multiple r squared adjusted r squared, and p-value. Let's start with residuals. What are residuals? They are the standard errors that occur when there is a difference in the values, like between the actual observed values and the response values the model predicts. So we can see there is a range in the errors. So the residual shows that there should be a symmetrical distribution across these points on the mean value of 0. Certain points are far away from the actual points. We'll plot these residuals, and we'll see if it's meet our assumption for the linear regression or not later on. Next is coefficients. Coefficients, as I have already discussed, intercept and the slope value. So here it is important to understand that my independent variable was height. Now what are these factors that are showing are, first, estimated standard error. So it shows the slope value, that is 3.45, that this much effect, 3.45 times effect will be there on the weight of the women when height increases, or whatever the value of will be height, correspondingly there will be 3.5 times effect on the weight. Next is the t value. T value shows the variation in the range of the height and weight. Next is the p value, that is 1.09 e minus 14. What it shows is, p value is very essential to understand in a model, as p value tells you if your model is built significantly or not. It should be less than 0.5. Whenever you are building a model, it tells that your model is significant. So there are two kind of p-values. One is for the factor and second is for the whole model. Both should be less than 0.05 in order to make it significant. Next is the significance code. So as you can see here, they have given the list of significance code. What it tells is, if there are 3 stars, it shows it is the most significant factor in that model. 2 stars shows it is less than the other factors. Similarly, we can understand the other points. And if it is not at all significant, there will be no star in that factor. Next is residual standard error. So residual standard errors, they are the measure of the variation of observation around the regression line. So whenever we are building a model, when we plot the line, Like we can see here how much there is variation between the observations. If any of the observation is out of the line, we can understand through this value.